Hi, welcome to my video on circles. This video is on converses number 2. When a conditional sentence and its converse are both true, they can be combined in an if and only if, written IFF statement. Let's do an example. If a segment is drawn from the center of a circle perpendicular to a chord, then the segment bisects the chord. So the converse, you switch it around. If a segment of a circle drawn from the center bisects the chord, then the segment is perpendicular to the chord. So what we mean there, just in case, we have a chord, we have the center. So if I draw a segment from the center perpendicular to the chord, then it'll bisect the chord. And the converse of that is that you have a center, you have a chord. So if you draw a segment from the center that will bisect the chord, cut it in half, then it'll be perpendicular. So we have, as a result, we have an if and only if, because the conditional sentence is true, its converse is true. So a segment drawn from the center of a circle perpendicular to a chord, if and only if the segment bisects the chord. So notice, this is the segment, this is the conditional sentence. If a segment drawn from the center of the circle perpendicular to a chord, then it bisects the chord. So there's this inverse. If a segment bisects the chord, then it's perpendicular. Now, the statement reads, the if is left out. You leave out the if, you leave out the then, and you put an if and only if right in the middle. So the if is left out, the then is left out, and the if and only if goes in the middle. A segment drawn from the center of a circle perpendicular to a chord, if and only if the segment bisects the chord, which means writing the if and only if statement, you can reverse it. So a segment drawn from the center of a circle perpendicular to a chord, the segment bisects the chord. It's converse. If a segment bisects the chord of a circle, then the segment is drawn from the center perpendicular to the chord. So the if and only if replaces the if and the then. Which conditional sentence can be written as if and only if? If so, state as an if and only if statement. The converse of this, if x is 2, then x squared equals 4. The converse, if x squared equals 4, then x equals 2. And that's false. Why? Well, let's just look. If x squared equals 4, then x is equal to plus or minus the square root of 4. X is equal to plus or minus 2. So if x squared equals 4, then x is 2. No, because x can be equal to negative 2. So it's a false. So therefore, since the converse is false, we cannot write it in the if and then form. Number 2, if a function is exponential, then its inverse is a logarithmic. And the converse is if a function is logarithmic, a log function. If a function is logarithmic, then the function is exponential. And an exponential function is like y equals 2 to the x. A logarithmic function of that is y equals the log of x base 2. So one is exponential, one is logarithmic, and they're the inverse of each other. So that means you can write out the statement: a function is exponential if and only if I just noticed if a function is logarithmic, if the function is exponential, or I could say if the inverse is exponential. And so I got to have inverse in there. A function is exponential if its inverse is logarithmic function. So the if and the then is left out, and the if is placed in the middle. Okay, let's do some more. Apologize for my writing, it's just not good at times. If a quadrilateral is a square, then the quadrilateral is a rectangle. So the converse, if a quadrilateral is a rectangle, then the quadrilateral is a square. Again, the reversed, but this is false because we could have a rectangle that's like this. So a rectangle got all right angles, but this side could be 10 and 10. This side could be 4 and 4. It's a rectangle, but it's not a square. Why? Because all sides are not equal. A square has to have all sides equal. So a rectangle is not a square. A square is a rectangle. If you have a square, then you have opposite sides equal because all of them are equal. But a rectangle is not a square. So because the converse is false, then we can't write it in the if and then form. In a circle, if an angle is inscribed, then its measure is half the measure of the intercepted arc. So what's this converse? So let's switch it around. The converse in a circle, if the measure of an angle is half the measure of the intercepted arc, then the angle is inscribed. So, just to explain that, I'll show you that that's true. But so that I'm going to write the if and then statement first. In a circle, an angle is inscribed. An angle is inscribed if and only if its measure is half the measure of intercepted arc. So because the statement is true, the conditional statement has to be true. This statement is true. The converse might not be true. So since its converse is, we switch the statement around and the converse is true, then we can leave out the if and the then and put the if in the middle. So because the if is there, that we know that is the statement and its converse is true. So let me just explain that one. If we have a circle and we have an arc, so let's say we don't need this. So let's say we have this arc, and the ends of this arc is AB. So what happens is that this angle right here, ACB, is inscribed because it's made of two chords with a common vertex. So this is an inscribed angle intercepting this arc AB. So whatever this arc is here, so let's say this arc right here is 70 degrees. That means this angle is half the measure, which is 35. And also it's true that if we draw a circle and we have an inscribed angle, just reverse it, go like this. This is an inscribed angle. And let's say this inscribed angle is, say, 50 degrees. That means that this inscribed angle, made of two chords with a common vertex, that means that this arc right here will be 100. So if the inscribed angle is half the intercepted arc, then if this is an inscribed angle, then it'll be half of its intercepted arc. That's the reverse. So the statement and its converse is true, so we can write it in the if and then form. And that brings us to the end of the video. If you liked the video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. Content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.